Good morning, everybody. Hope everybody's doing well. It's been brought to my attention by a couple of students that yesterday's lecture did not upload properly. I actually tried to upload it a couple of different times, and for whatever reason, there's some issues. Tech support is aware of this, so once I get a response as to why there's an issue, then I'll go ahead and upload it again. If I don't get a response by tomorrow, or it's not resolved by tomorrow, I'll try to upload it either on a Google Drive and share it with everybody, or upload it onto YouTube, just so you guys have the ability to watch it. Hopefully there's no issues with uploading this lecture, but we will see. Hopefully you guys are all finding this week's material interesting, because most of it I feel like you guys can take with you into your lives after this class. And today's lecture should be no different. So today I'm going to be focused on carbohydrates and some of the diseases that are associated with high amounts of sugar. I gave you guys a preface to some of the key nutrients that we need to survive. And so for the rest of the following lectures, I'm going to be focused on the key macromolecules and some of the things that they're associated with when it comes to disease manifestation. So today's outline, I'm gonna give you a little bit more information to what carbs are than I did yesterday. I'm gonna emphasize some of the different names for them and the different types and where you can find them. And then I'm gonna be emphasizing fiber, as it is a type of carb. I'm gonna go a little bit more in depth on how the body is able to absorb carbohydrates, and then be able to apply the hormones, insulin and glucagon in this absorption process. I'm also going to cover the differences between glycemic index versus glycemic load. And then I'm going to talk about how sugar is implicated in type 1 and type 2 diabetes. And then I'm also going to talk about how we test for type 2 diabetes. So what I really want you to take from this lecture is understand the different names that we have for carbohydrates. We see them on the back of food labels, we hear them all the time, but people get so confused as to what they are. And I want you guys to be more educated on these terms. And so that's why I'm going to end up testing you guys on some of them, because I think they're an important part of your vocabulary for you to understand. I want you to understand the basic process of how our body is able to intake these carbs, and how we're able to basically process them, because understanding this process will also help you understand my last learning objective when it comes to understanding type 2 diabetes. Again, I want you to understand the difference between these two hormones and their implication into the absorption process, and then understand the difference between glycemic index and glycemic load, as they're similar but different. So let's go ahead and start at the very basic unit of what a carbohydrate is. All carbohydrates are made of monosaccharides, and mono meaning one and saccharide meaning sweet is just one sweet molecule. And so they're made out of a range of different kinds of carbons. The range can be anywhere from 3 to 7. They are associated with our body being able to synthesize the building blocks of nucleotides, such as ribose and deoxyribose, as I covered in lecture 2. But our body synthesizes those. What we really are going to be talking about here is when we consume carbs and how we utilize this for energy. The most common monosaccharide you are going to typically hear are going to be glucose. And then some of the other key ones are going to be fructose and galactose. So what happens when you combine a couple of these? Well, when you combine a couple of these, then you're going to get disaccharides, or two sweet molecules. And basically, two sweet molecules together are disaccharides. And there's a couple of different combinations, but they all have glucose attached to it in some way. So two glucose molecules attached to each other is going to be maltose. And maltose is usually found in different kinds of cereals, candies, and used in brewing beer. Glucose attached to a fructose is going to lead to sucrose. And this is typically what you're going to find. This is what table sugar is. So this is going to be a refined version of sugars, white sugar. This form of the sugar is also naturally found in fruits, vegetables, and honeys, but the whole, purification process out of all of these natural um, uh, uh, organisms is how we end up using it for table sugar. And then the last disaccharide is going to be glucose and galactose, which is going to lead to lactose, which is just going to be your sugars found in dairy products such as your milk and yogurt. So when you begin linking these all together, you're going to get polysaccharides. So poly meaning many. So many sugar or sweet molecules stuck together. And there's a couple of different forms of them, but the main ones that I'm going to go over in this class that are relevant to nutrition are going to be glycogen, starch, and cellulose. Here I have examples of what these particular polysaccharides look like. So we're going to find starches and cellulose in plants. And so the starch component of plants is usually going to be the sugars that the plant synthesizes for itself so it can go and consume it for energy. Whereas the cellulose is going to be synthesized for its cell wall. And this is going to be where our fiber comes from. It's going to be the cell walls from the plants that we eat. As opposed to animals, when we end up in taking these carbohydrates, basically we like to store some of them, and we end up storing some of our excessive sugar in our liver and muscles for later usage. And the form of this storage are called glycogen. So the main carbohydrate I really want to focus on in terms of it being healthy are the benefits of fiber. So again, fiber is a type of cellulose that's found in plants. And this is going to be the main source of where we get our fiber from. The daily recommended intake for fiber is around 25 to 30 grams a day. However, the typical American eats 10 to 15 grams a day. And, in my opinion, this is probably a high estimate. It's probably closer to 5 to 10. But we do not eat enough fiber in this country. Fiber has a lot of different benefits that are going to help with reducing a lot of the diseases that plague this country. The first one being it helps prevent heart disease. And the reason why has to do with the fiber is able to prevent the absorption of bad cholesterol. So when I go over the fat lecture, I'll go ahead and highlight this again. But there's different kinds of cholesterol. There's good and bad, which are both forms of lipids. And basically, when we absorb or eat fiber, the fiber kind of gets in the way of this bad cholesterol. And so if it's inhibiting the bad cholesterol from binding to the intestinal wall, then your body cannot absorb it. So it just reduces the amount. It helps with weight loss. So with fiber, it actually helps you feel fuller for longer. And so you're not wanting to eat as much. And so that's what I tell you, eat your fruits and vegetables before you start eating on all the delicious goodness, because basically your stomach's going to expand and it's going to register as being fuller. And if you register as being fuller, you're not going to want to eat as much. Fiber also helps control your blood sugar. So like with the bad cholesterol, because fiber is such a big molecule, it's a lot harder for the body to process because it needs to break it down because it has all of those polysaccharides stuck together, whereas the body needs to absorb only in the monosaccharide form. And so if you have these really long chains of sugars, the body's going to need more time to process that. And when it takes more time to process it, basically is going to release sugar into the blood a lot more slowly. And here I have a nice diagram of fiber that comes from corn, and basically the amount of sugar that is administrated into the blood. And so I really want you to pay attention to this particular curve and noticing how long it is, because when we're talking about foods that are going to lead to high glucose spikes into the blood, those are going to play a role when it comes to manifesting into diabetes. Um, One of the other main benefits of fiber is it helps keep regular bowel movements. And with this is going to come preventing digestive tract diseases. And the one digestive tract disease that I really want to highlight is diverticulitis. So diverticulitis is a condition that happens when these small sacs in your lower part of your colon become inflamed. And this is really due to years of straining this region when you're trying to poop. So if you're struggling to poop and you're putting a lot of strain on the blood vessels all at the end, years of that is going to lead to this. And like I said, Americans do not get enough fiber in their diet. And so right now it's estimated that 35% of Americans under the age of 50 have this. And basically, Americans over the age of 50, 1 or 2 out of 3 are going to end up developing it in their lifetime. So really, I'm going to emphasize increase your fiber intake, and start it while you're young so this doesn't develop when you're older. Fiber feeds your gut bacteria. I've emphasized gut bacteria in the immunology lecture when it comes to protecting us. And basically, the way that it's going to protect us is by outcompeting pathogenic bacteria, or bacteria that's going to make us sick. And the way that it's able to do this is by inhibiting bad bacterial growth, so outcompeting. It's going to be able to prevent the bacteria from attaching to the intestinal wall, and most bacteria need to actually get into a cell in order to, cause disease. And then also, when bacteria is in the process of trying to invade, it secretes different kinds of toxins. And so your gut microbiota are able to absorb some of these toxins and destroy them to keep us safe and healthy. The way you're going to keep your gut microbiota happy is really in 2 different ways. One, you want to feed them. And the way you're going to feed them is by giving them prebiotics. And I'm sure you've heard both pre and probiotics in the media. People are always trying to sell the new and latest thing. But I feel like a lot of people don't understand what these are. And prebiotics are just basically the plant fibers that are going to feed your good bacteria. Your bacteria utilize those kinds of sugars, those types of carbohydrates, to basically function and secrete some of the things that are needed to protect us from pathogenic bacteria. And so if you're feeding your bacteria these good things, then your overall health is going to be good, because they're also a source of our fats that we end up consuming. Most people don't know this, but one of the byproducts of bacteria when they're consuming some of these prebiotics is by synthesizing short chain fatty acids, which we can utilize in our diet. And I think they synthesize somewhere between 10 to 15% of what we actually use. So that's quite a bit. And then the other thing is, adding more of this good bacteria to your gut. And these are what are called probiotics. And you're going to be able to find basically good kinds of bacteria, good probiotics in things such as yogurt and kimchi. And so the more probiotics or good healthy bacteria you have in you, the overall better health you're going to have. I've talked about regular sugar, but we also have to talk about artificial sweeteners. So artificial sweeteners are going to be X amount of times sweeter than typical sugar. And so here I have the example of some of the names of the type of fake sugar that exists and what brand name you can find them under, and the amount of times sweeter that our receptors register as being sweet. And like I was saying in yesterday's lecture, I don't know about you, but for myself, when I'm tasting any of these fake sugars, it just doesn't taste sweet to me. It doesn't taste right. And so things that have artificial sweeteners in them, I stay away from, because they just don't taste good. But there are some people where it hits the receptor just right and they love this stuff. The only natural sweetener that's out there that isn't sugar comes from stevia. And this is basically a plant that has this, it's not fake sugar at this point, but it's not sugar, it's a natural sweetener. And this is going to register on the receptors 200 to 400 times sweeter than the typical sugar molecule. Studies have shown that people that drink artificially sweetened drinks are actually heavier. And most people are going to be surprised by this because they're thinking, oh, I'm staying away from sugar. Are you really? But you're staying away from it in the drink form. But the reason why a lot of these people, or studies are finding that these people are heavier, is because they're still eating more. So, people scrutinize sugar for being bad and causing all these diseases. But again, as I just showed you, it depends on the source of the sugar. And if you're drinking a Coke versus getting your sugar from fruits or vegetables, the way your body's going to process it is going to be quite different. And so on top of that, if you're substituting fake sugar for real sugar, your body runs on sugar. And so one of the ways that your body registers that it's full is by the amount of sugar that's present. And so if you do not have sugar in your diet, your body's going to be hungry still. And so a lot of these people that are drinking these artificial sweetener or sweetened drinks are usually hungrier still because their body is, drinking stuff that doesn't have any sugar in it. And so these people are going to tend to eat more. So how does our body actually process this? So I highlighted some of this yesterday, but now let's go ahead and talk a little bit more about some of the key organs that are involved and what happens how you store it, if you have an excessive amount and whatnot. So, again, glucose, sugar, carbs, all of that comes from the food that we eat. And it all starts by putting this food in our mouth, and our mouth, stomach, and intestines all have different kinds of enzymes. The main one is going to be amylase that helps break down these carbs. And so as I showed yesterday in the mouth, you're chewing, so the amylase isn't going to have enough time to break all of the sugar down, but it's going to start the process. And then when you have amylase in the stomach and the intestines, it's going to help break it down further. And so the way that we're going to absorb this is once it's in the mono form. So in the glucose or fructose or galactose form. Once it's in this form, the intestine can basically absorb that because it has these glucose transporters on them. And this is going to facilitate the transport into the bloodstream. Once the sugar's in the bloodstream, the body is going to receive the signals that there's blood in, or there's sugar in the blood that's above homeostatic levels, and insulin is going to be secreted. And so insulin is going to basically tell cells in the body, allow your glucose transporters to absorb this excessive sugar that's in the blood. And the cells are going to use this for energy. And any excessive energy that is still left in the blood is going to be stored in the form of glycogen in your liver and in your muscles. Now, there is a finite amount of storage for these types of carbs within the muscles and liver. And so if you're consuming a lot more extra sugar than you should be, then it's going to end up getting converted into fat. And this is one of the reasons why we have the current obesity pandemic. So glucose moves through cells via transporters. So I emphasized this once in one of the, I think in the organelle lecture when I was talking about the cell membrane, but all of our cells have glucose transporters in them. And the main point of these transporters is so they can facilitate the transport of these different kinds of monosaccharides into the cell. So when glucose is broken down into the intestinal area in its monosaccharide form, these different types of glucose transporters are going to transport the glucose into the cell, or the sugar, fructose as well. And so again, your body uses sugar to function. And so a lot of the time what's going to end up happening is your cells are going to convert any molecule, so fructose or galactose, into glucose, but it's not going to do all of it. It's going to do some of it. And so then after it converts most of it into glucose, it's going to secrete it into the bloodstream so other cells can go ahead and pick it up. With some of the other sugars, fructose and galactose, they're also going to be secreted into the bloodstream at lower levels, but other cells also have some of these transporters where they can actually convert these sugar molecules into glucose. And then, once it's actually in the bloodstream, then the rest of the body can absorb it. Somebody asked me, what's your opinion on cutting sugar off of your diet? It really depends on the source of your sugar. If you're cutting the sugar out of like Coke and, all of these processed refined sugars, then it's a great thing. You're probably not going to get diabetes. If you're intaking your sugar from fruits and vegetables, you're probably going to be okay. But if you're cutting it out completely and you're just consuming fats and proteins, that's going to be very bad for your cardiovascular system, which I will show you in next week's lecture when we're talking about lipids. So glucose is used by the cell for energy. And so, as you guys should all know at this point from my lecture one and all the memes that you've seen throughout your life, the mitochondria is the powerhouse of the cell. And the reason for that is because it makes energy. And the way it makes energy is by uptaking these glucomolecules and processing them to make the energy. And so there's this whole different cycles that basically facilitate this process. I'm not going to quiz you on any of that. It's beyond the scope of what I think you should know. But I do want you to understand that this is why the mitochondria is the powerhouse of the cell. It utilizes the sugar so it can basically undergo these different biochemical processes to produce different amounts of ATP. And so this whole process of breaking down glucose for the usage of this whole cycle is called glycolysis. And so glyco meaning sugar and lysis meaning breakdown. So it's nothing fancy, just the breakdown to sugar. And so I do want you to understand some of this terminology. And then again, the main output energy from this whole process is going to be energy in the form of ATP. And then also in this process, another byproduct is going to be carbon dioxide. So we take in oxygen and sugar, and then we breathe out the carbon dioxide and make energy. So you want to keep homeostatic levels of sugar in your blood. Again, I'm going to emphasize multiple times, your body needs sugar to live. There's more biochemical pathways to synthesize sugar than there is to make fat or protein. And so the amount of sugar in your blood is going to be regulated by two main hormones, insulin and glucagon. And so when you haven't eaten for some time, so this is what this fasting refers to, your blood sugar level usually stays within the 70 to 99 milligrams per deciliter range. And so this is typically going to be mediated through glucagon. So if your sugar levels are too low, the glucagon is going to get produced and tell your body to basically release sugar into the blood so it stays within this range. Now, when you eat a meal, especially one that has a lot of carbs in it, this is going to release the the sugar back into the blood, and it's going to raise the amount of sugar in the blood. And so your body wants to keep a relatively constant amount of sugar in the blood, because too much sugar in the blood is actually bad for the body. And so when it reaches a threshold of it being too much, where it's out of its normal range, insulin is going to be secreted. And that's when insulin is going to basically signal to the insulin receptors so it can tell cells start uptaking the sugar out of the blood and then use it for energy. So here I have a comparison of insulin versus glucagon. So again, these are going to be the two hormones that regulate the amount of sugar in the blood. So here I have a picture of the pancreas. So this is going to be where your glucagon and insulin are secreted from. And within your pancreas, you have a few different cell types. But the cell types I really want you to pay attention to are your beta and alpha islet cells. So these are going to be a specialized kind of cell that lives within your pancreas. And so once the body tells the pancreas there's a high amount of sugar in the blood, it's going to tell the beta cells to produce insulin so it can reduce that level within the blood. Now, again, if you're fasting and your blood sugar levels fall beyond the normal set point, it's going to tell the alpha cells to start secreting glucagon. And this is going to basically tell the liver, break down some of that glycogen that you have in your storage, and start releasing some of that back into the blood so it's back to normal levels. And so here I have a nice graph kind of depicting that whole process of glucose regulation. So, here we have the beginning of the introduction of a high carb meal. Here we have the typical normal range of what your sugar level should be. And basically, once your amount of glucose ends up spiking in your blood, the pancreas is going to get the signals to tell the beta islet cells start producing insulin. And then you're going to get this insulin spike that is going to help lower the amount of glucose in the body. And so if your amount of sugar is below threshold, then glucagon is going to end up getting secreted. And so glucagon is the one that really keeps everything stabilized when you haven't eaten anything. So now what we want to talk about is glycemic index. So with glycemic index, I'm sure a lot of you guys have heard this. It's really trying to develop a system that's going to rank food from 1 through 100, based on their effects on the blood sugar levels. And so here they have the basic defined regions and what's considered something that has a high glycemic index, a medium, and a low. And so something with a high glycemic index is going to cause a lot of blood sugar, your blood sugar to raise, whereas a food that has a low glycemic index is going to cause it to not spike and basically gradually release sugar into the blood. So foods with low glycemic index typically take longer to process and thus is going to cause not really much of a spike. It's going to be this gradual curve where, again, the high GI foods are going to be able to get broken down faster because they're typically going to be simple sugars. And those simple sugars, because they're so easily broken down, are going to be released into the blood immediately. And this is going to cause this spike in glucose in the body, which subsequently is going to lead to a spike in insulin. And so the way that whoever invented the glycemic index, the way that they basically did this is they had people fast overnight, so typically about 12 hours, just so they can keep their blood sugar level at a relatively constant range. And then what they did is they gave them a test food. And the test food was typically some kind of food that had carbs, 50 grams of carbs in it. And so in this particular measurement, they did not incorporate the amount of fiber that was in there. So basically, all kinds of carbs that are present in there were not distinguished from one another. And so basically what they did is they fed these people 50 grams of carbs of different kinds of foods. And then they measured their blood sugar levels every 15 to 30 minutes over a span of 2 hours. And they basically plotted this on a line. or on a graph, and then you can generate this line. And then, after the level of blood sugar level went back down to homeostatic concentrations, when it comes to any kind of test, you're going to want to have some kind of control. And so the control that they used was just pure glucose or white bread. So they gave the study group either 50 grams of glucose, which is quite a bit, or 50 grams of white bread. And basically, this is the kind of curve that was generated. So it's going to cause an insulin spike because this is quite a bit of sugar in the body. And so then they set this positive control as set to 100. And so the area under the curve of this is 100. And then what they did was they overlapped these two curves, and basically the area under the tested food was divided by the total amount from the control food, and that number is how your GI value is determined. Now, with glycemic load, it's a little similar, except in my opinion, I think it's a lot better, but it still, needs some improvement. The glycemic index does not take in consideration the portion size. So when they're giving these individuals 50 grams of carbs, of whatever food that they're testing, a lot of the time the food that they're giving them is in excess. It's not a typical portion size that a person typically eats. And so, of course, if you're giving them something that's way too much, of course, they're going to have high amounts of sugar in their blood. And so the glycemic load basically kind of, fixes this a little bit by taking consideration the portion size of the amount of carbs that are present. And so the way they do this is basically they take the amount of available carbs that are in a portion, subtracting it by the amount of fiber that's present, and then multiplying it by the glycemic index, and then dividing that by 100 to get these different ranges. And so for the glycemic load, basically anything below 10 is going to be considered good, and anything above 20 is going to be considered bad. And so here I have a comparison of fruit versus white bread, and this is all accounts for a typical serving size that people will eat. And so we can see with how, utilizing the glycemic load, it kind of corrects this a little bit, where if we look at the fruit, most of the time it's when you're just utilizing the glycemic index, it's going to be in the medium or high range, versus when you account for the amount of fiber that's in here, then it's going to end up, fixing it a little bit where it's actually indicating that it's healthy. Whereas some of the, carbs that are, we now know aren't really good for us, some of it, stays relatively high. So the GI for this is going to be 70, where the glycemic load is still, it's better. It's not in the high range anymore, according to this range and definition. But it's still, it's still not the best. And so I have to emphasize that the glycemic index and glycemic load can be useful for seeing if some kind of food is going to cause a spike in your blood sugar levels, but it is not a perfect system. When you have low values for a glycemic index or a glycemic load, it does not always mean that the food is healthy, and vice versa, of something being high and it being unhealthy. When you're taking consideration the kinds of food you're eating, you need to take in consideration the fat content. So as I showed you yesterday, fat has a high amount of energy in it, and so it's going to be harder for the body to break that down, and so it's going to process a lot slower. That's why they say fatty foods are typically going to be heavy on the stomach, because it takes a lot of energy to break them down. You want to consider the fiber content. The fiber content is going to slow the amount of sugar that's released inside the blood. And then finally, you want to consider how processed is the food. The food the more processed food is, it's typically going to raise both the glycemic index and the glycemic load, because a lot of processed food are going to have these added sugars to them. And so here I have basically prime examples of how the GI and the GL are not all that helpful. So we take a bowl of ice cream and we see that the glycemic index indicates that it's in the good range, it's healthy, because the majority of this is composed of fat, so it does take it a little bit longer to process. But you also look at your glycemic load and it's in the medium range, but we all know that, you know, this excessive amount of fat and sugar is going to cause weight gain. Now, when we look at a very healthy carrot that has a lot of nutritional benefit to us, when you measure it based off the glycemic index, it has a glycemic index of 91, which is indicating that it's bad for you. But when you're measuring the glycemic index, you're not typically eating 50 grams of carrots. You're only eating like 1 or 2. And so when you actually account for the amount of fiber that's present, which, you know, the majority of it is fiber, then the glycemic load is going to be 1, which is quite healthy. So, you know, consider this when you're looking at some of these numbers, if you're ever, you know, trying to figure out if you should be looking at a food that has any of these respective values. So how does sugar lead to disease? So it's dependent on, you know, what disease you're talking about. And I feel like the majority of sugar is going to lead to type 2 diabetes, but people always get type 1 and type 2 confused. And so, you know, this is something I am going to expect you guys to know, because it is important, because I'm sure you guys, some of you guys out there have family members that have either one or both. And so it's for your best knowledge to understand, one, what's the difference between these two, and two, how they manifest. And so when it comes to talking about type 1 diabetes, typically this is going to happen in younger people. And so the other name for type 1 diabetes is called early onset diabetes. And so the reason why this happens is because type 1 diabetes is an autoimmune disease. Basically, you know, you guys all have a preface to immunology now. Typically, you know, there's that whole process of the innate, recognizing or educating the adaptive. The body is really good at recognizing when something is foreign and when it's self, but it's not always. And so with some of these people, basically your adaptive immune cells are recognizing self as a pathogen. And one of the antigens that the T cells are recognizing are your beta islet cells, the ones that secrete the insulin. And so once they register that this is a pathogen, then they basically go into the pancreas and kill off all of these beta islet cells. And if you no longer have beta islet cells, then you can no longer produce insulin. And so this is going to lead to type 1 diabetes. And so basically these patients need to secrete or inject insulin into their bodies in order for them to actually be able to process the sugar, because high amounts of sugar in the body is bad. Now, when we talk about type 2 diabetes, this is also called late onset diabetes, because this is typically going to happen in people that are older, usually after the age of 45. When we're looking at the proportion of people that have diabetes, 90% of diabetic patients are going to make up the type 2 diabetes category, whereas the type 1 are only going to make up the 10%. The reason why type 2 diabetics, you know, end up getting this is because they're constantly having glucose spikes in their body, which is going to lead to insulin spikes, like I showed you in that graph. And so here we have a normal healthy function that happens in our body. So we have our pancreas that registers that there's a lot of sugar in the blood. It's going to secrete it into the blood. And then once insulin is circulating within the blood, it's going to bind to the insulin receptor. Once the insulin receptor is stimulated, it's going to tell these glucose transporters on the surface of the cells to start intaking glucose. So it reduces the amount of sugar that's in the blood, and that sugar can also be utilized as energy for the cell. Now, as I kind of emphasize on the two graphs, you have things when you're intaking carbs that are going to lead to high amounts of glucose in the blood, and ones that are going to kind of have that nice gradual release of glucose into the blood. The foods that are going to cause those big increases are going to be like all the simple sugars that we find in like cakes and candies and all those things that we really love. Um, you basically abusing your body by eating all of these for many decades is going to lead to type 2 diabetes. Eventually, your insulin receptor is going to stop responding to the insulin. And scientists are still trying to understand why this is. We don't really know. But what we do know is there's this, it's called insulin insensitivity. So the insulin receptors are desensitized to the amount of sugar in the blood. If you don't have these receptors getting stimulated, then you can't tell these glucotransporters to take in the glucose from the blood. So a lot of the sugar stays within the blood. And the amount of sugar that's in the blood, I think it's after like 200 milligrams per deciliter, is very toxic to cells for a variety of reasons. I'm not going to really go into the different manifestations of the disease, but just for your guys' quick knowledge, basically what ends up happening is your body's trying to flush out a lot of this excessive sugar. But a lot of this excessive sugar is very straining and taxing on your kidneys. And so that's why a lot of type 2 diabetics and some type 1, but mainly type 2 diabetics they have kidney disease because they're constantly trying to flush out all this excessive sugar, and that damages some of the kidney structures. And when you have those damage to your kidney structures, your kidneys are not going to function very well. And on top of that, a lot of diabetic patients will be very thirsty because they're basically utilizing all of that water to flush out this excessive sugar, because it is very toxic to your cells, and it's also very toxic to neurons. High concentration of sugar is going to basically kill off some of your neurons. And so that's why you'll see some patients, type 2 diabetic patients, that will end up going blind, because we're able to see through the neurons that transmit all the information to our brain. And so if those neurons are dead, then none of that information can get transmitted. On top of that, when we're feeling stuff, those are all neurons as well. And so a lot of patients that are diabetic, they'll end up, they won't be able to feel pain because a lot of their neurons in their periphery will end up being dead because of, there's a couple of different reasons. Some of it has to do with their vasculature getting damaged. So there isn't enough nutrients that's going, and so that's going to lead to the death of tissue. And so that's why you'll see some diabetic patients that end up losing some kind of limb because they get some infection that they weren't aware of, and then it manifests into basically necrosis, where the tissue is starting to die. And you do not want that getting into the blood. Once a bacterial infection gets into the blood, it's almost game over. It leads to something called sepsis, and your blood basically gets poisoned. And so this is, some of the what they're called diabetic complications as to why diabetic patients succumb to diabetes. It's not the diabetes itself; it's some of these damages to the body that end up leading to death. So here I have a graph of both the number and percentage of Americans that have developed type 2 diabetes within the last century. And so we can see that both with the number and percentage of people that are developing diabetes, we have a very major issue in this country. We have just way too many people that are developing diabetes, and this is very taxing to the healthcare system. And a lot of diabetic patients, I'm sure you're aware of, are also obese. And so here's a graph that's showing an increase of our sugar consumption from 1820 all the way to 2000. And so we can see this upward positive trend of the amount of sugar that we're consuming in our diet. And as I showed you at the beginning, when it comes to the absorption of sugar, if we're intaking an excessive amount of sugar, our body is going to end up storing it as fat. And so we think that, fat is the main cause of why we're all obese, and it contributes to it for sure. But the main cause is the amount of sugar in our diet. We eat a whole lot more sugar than the other two combined. These are the two reasons why we have both the diabetic and obesity epidemic. And when we look at, this correlation between this high fructose corn syrup, it was originally invented in 1970. And then, the food industry always has a say in terms of what it's selling. And basically, this, typically comes from corn because, we're one of the main producers of corn in this country. So basically, for monetary reasons, we paid farmers to make all this because it's a simpler way of making a type of sugar rather than extracting it from sugar cane. And scientists believe that with this increase of this particular type of sugar in our diets and all of our foods is the reason why we have this exponential increase of obesity in the last few decades. We are continuing in an upward direction of increasing obesity in this country. Here I have a diagram of people that have been diagnosed as diabetic with respect to their different states. And so we can see that in 1994, there were some rates of diabetes that were occurring, but as you increase with respect to time, we're seeing that it's getting a whole lot worse. And unless there's some kind of educational intervention, it's just going to keep on getting worse, because in this country, we like to solve our issues with a pill in some way by, losing weight, or by, insulin injections, or some metformin, which is another type of drug that diabetics use to regulate the system. But we don't try to do what we should be doing, which is, actually, before I even get into that, sorry, I'll talk about how we diagnose it. So basically, and these are things that you guys should be aware of, because if you're ever getting some kind of blood panel done, you're going to see some of these tests, and it's a good idea for you guys to understand what they mean. And one of the most common tests that have been recently used, I would say within the last decade, is this A1C test. And so this A1C test is basically used to diagnose diabetes. And it's this plus measuring the amount of sugar that's in your blood. And so what this test basically looks at is the amount of sugar that is on your red blood cells. So here I have a picture of a typical red blood cell, and it has these proteins within them called hemoglobin. And hemoglobin are going to be the key proteins that help carry oxygen throughout your blood. The hemoglobin proteins will end up also binding to the sugar that's in the blood. And so this process is just called glycosylation. So it's just like glucose binding to the hemoglobin. And so we're able to actually, measure the percentage of glucose that is bound to a red blood cell. And typically, if you get the test done once, you're going to want to get it done, at least 3 months after that, because we have a turnover rate of our red blood cells every 3 months. So every 3 months, we're basically getting a new round of red blood cells, as this is the lifespan of a typical red blood cell. Now, basically, the higher amount of glucose that's in the blood, the more sugar that is going to be bound or found on the hemoglobin of the red blood cells. And so when doctors or technicians are running this test, basically they're looking for the percentage of glucose that's found on the cell. And so here, basically anything below 5.7% is considered healthy. Between 5.7 and 6.5% is pre-diabetic. This is going to be, your warning sign. So if you get your blood test done and you see that you're within this range, hopefully you'll do something about it before it manifests to full diabetes. And anything above 6.5 is considered diabetic, because you're just having way too much exposure of sugar to your system. And so in tandem to this A1C test, doctors will have you do a couple of different things when they're measuring their blood. They want to see what your resting glucose levels are, your fasting levels. So when I talked about how diabetes, or sorry, not diabetes, your blood level, sugar level should be within this range. Well, at fasting, diabetic patients is usually runs high. It usually runs between 80 and 130 because again, they're insulin insensitive, so their insulin receptors aren't being stimulated, so a lot of the sugar stays within their blood. And so when they end up consuming a meal, it's going to be significantly higher than somebody without diabetes. And you know, I have diabetic family members like my grandfather, and I've seen after he has a meal that even at resting, it's around 200, which is, you know, very toxic to your system. It is not good to have that amount of sugar in your blood. And so, you know, these three numbers usually are going to be what tell the doctor you have diabetes. And so you want to go ahead and try to improve your type 2 diabetes. I believe that there is a point where you can reverse it after you're diagnosed, but I do believe there is a point of no return for some individuals that have just been abusing their body for decades and just, you know, don't do the typical things that you need to do, like changing your diet. You know, this is type 2 diabetes is all caused by your diet. It's not caused for any other reason. At least, you know, no scientist has demonstrated that. If we just lower intake of processed sugars and increase our intake of the good sugars like fibers, we could definitely lower the amount of sugar that is found in our blood. On top of that, exercise is going to be the thing that saves some of these patients, because exercise, when you're stimulating your muscles either by running or by lifting weights, your muscles run off of sugar. That's their main like fuel source. And so when you end up exercising, you basically start to upregulate or put more of these transporters on the cell surface of the muscles. And so here we have a graph of somebody that's at resting and their base level of the glucose transporter 4. And then what happens when they start to exercise? We see that around the amount of transporters ends up doubling. Now, when we measure the amount of glucose that the body is able to uptake, we see that at rest, you know, it's not really uptaking anything because it's kind of keeping a homeostatic level. But then when you start to exercise, you know, you're also releasing sugar and burning fat in the process. So the fat can be converted to sugar so your body can use it. And so your muscles need that sugar to run. And so basically the muscles are much more efficient at uptaking the glucose from the environment. So these are going to be the two main ways of being able to get your type 2 diabetes under control. Those are going to be the main points that I really want you to know. At this time, I'm going to take some questions. I see a few in the chat now. I wanted to you know, make sure I cover all of this before we run out of time. I will stay and answer these questions. And for those people that want to go, here is the the sign-in sheet. So I'm going to start going one by one through some of these questions. So so question, is type 1 diabetes hereditary? I think there is some genetic link to it. But again, we still don't know the full reason as to why our body attacks ourselves. There is scientific evidence that shows so when a T cell is recognizing a antigen from an MHC, it recognizes specific proteins on the MHC complex, and we have a couple of different kinds. And some different kinds of studies have been done to show that there are certain kinds of proteins that make up those structures that are correlated with both type 1 and type 2 diabetes. So in order to avoid getting diabetes later on, we should avoid getting glucose spikes. Absolutely. Yeah, if you avoid those glucose spikes, you're not going to have that insulin insensitivity. Somebody asked, so only type 1 inject insulin then? How do type 2? No, type 2 also inject insulin because they need to break down the sugar in some way. But we need sugar to process. So both will end up injecting insulin. But they also undergo different kinds of drugs. So I know metformin is a drug that type 2 diabetics will use. I don't think type 1 use it, and I think it has to do with the mechanism it targets. Somebody asked, so why again do some diabetics need to amputate their limbs? It has to do with not recognizing that they have an infection on their foot. It's usually on their foot. Because they're not, a lot of them, they're not looking at their feet all the time because a lot of them are living a sedentary life, just sitting all the time. But what ends up happening is they end up developing some kind of lesion on their foot. And that lesion, if it continues to go untreated, is going to manifest into a very nasty infection. And as I was saying, when it comes to high amounts of sugar in the body, the high levels of sugar will kill off both some of your neurons and some of your vasculature. And so your immune system, uses your vasculature to go into different parts of the body so it can go ahead and fight off disease. Well, if you have very poor vasculature in your extremities, then your immune system can't really get to the sites of infection, so they're not going to be able to clear it. And if they don't clear it, then that infection is going to manifest itself. So that's why a lot of diabetics, they need to go and see a doctor and get antibiotics immediately, because that's going to be their only way that they're going to be able to kill that off. Will viral infections lead to bacterial infections? I don't know about in the context of diabetes, but in the terms of opportunistic infections, absolutely. So that's why there are some doctors that will prescribe patients that have some kind of viral pneumonia with an antibiotic, because some of the immune system, when it's responding to the viral infection, it ends up inhibiting some of the immune system that's going to respond to the bacteria. And so if you're having these inhibitory signals to fight off the bacteria, then the bacteria can start to manifest itself. So the prime thing that the immune system will fight against first are going to be the viral infections. And then because of that, opportunistic bacterial infections will end up forming. So that's when antibiotics are handy. Somebody asked, a lot of diabetes is also picked up through our eye exams. We see diabetic retinopathy so often. I work on, and so it has to do with the neurons, like I mentioned earlier. Is there an opposite condition to diabetes, not getting enough sugar in the diet? There's hypoglycemia, and so I wouldn't say that there might be a condition. I'm not sure of it, but what ends up happening with a lot of type 2 diabetics is if they're not monitoring their sugar very well, what's going to end up happening is they're going to give themselves too much insulin. And if they give themselves too much insulin, then too much sugar is going to get broken down. And like I've emphasized multiple times, our body runs off of sugar. And so I believe it's, if you go below 40 milligrams per deciliter, that's actually, it can lead to seizures and death. And that's actually happened to my grandfather a couple of times, where he didn't eat anything. He had given himself insulin like a few hours before, and he ended up having some seizures because your body, it basically throws a lot of the neurotransmitters out of whack. And that leads to like a lot of firing in your brain, and that's going to lead to a lot of problems. Any other questions? Feel free to unmute yourself as well.